we can't go for that. Okay, so again, so now this is second point, is that first of all, like we are working in the industry, the most of Leicester, in the asked that why we need that, right? So that also is very clear that your life, I think you are working in the special. I have the experience, I have sorted special for the petroleum inventory, steel inventory is happening basically in the industry. Late are consuming a lot of water to make any what processor core. So in the industry we are consuming too much water. So basically there were issues with the drinking water, there were utilization of the water, agriculture. So there were industry, like there were cooling processors and Rios, there were water, there were cooling towers. So what do you think? Is this the cooling tower mean? Like suppose you have steel processors, you are melting something, making some other object. So we are reaching the very high temperature, like 11 and 4th or the degrees. Then the processor is cold. The RT, repeat thermal processor, like basically we are quickly making the temperature down and the water is available. So in the demand D, we are doing the radar, then throwing the water, always clean water outside. They are doing the purification inside the factory and doing the temperature down. For example, like suppose we have the temperature late, I can say that like I have the temperature, for example, like 200 degrees. I can't let it, Yahoo, the reason is the will change, the nature will change the face. So how this behavior is working, like we are taking the So Digital processor where your temperature is increasing, and then we have taken the hot water and traveling very high aspect. We can take more 100 meters of the 200, 300 meters according to the industry where you are using that. And then late is the levels of steps to divide the water morning. In the small masses, because of heat is directly proportional temperature difference mass, and there were specific heat conductivity. So that was the reason for traveling, was water from drop to down, and then breaking was huge amount of the water in the small parts of the mass. And second case vote that we are doing that. The air is also available, so that we are applying the air from the downside. Then again, they can absorb where cold air, and they try to minimize was temperature. So this is the cooling tower application. So in this room, we know that like quite using the real line. Second case is that like for simulate the scenario, like what we get, bring it here, like we have this is cold, the water storage point here, and we are applying a heater. If you want the very fast processor, you can put your heater also, okay? Like if you support, you have the lab, generally the women to turn on. I started, I think 10 minutes or 15 minutes before, so it will take time because here it is. We have felt almost 40 liters of the water, so definitely to take a little bit time to get it all. So what we are doing, that this is called a drain line, and the bags and the R putting at the heater, and then now I said that to fill our processor, what we have been. Like we have connected with the pump. So second thing is that why did the pump? The answer is that basically we are taking the pump, and the pump connection is going to top late, okay, from the top. Like we have the hot water pump, we'll throw the water in the top, give the water, will come here, and again, like in the industry also, what we are doing that basically we are making the channels of the water directly. We are not seeing the water. So the same way we mean the sum of the whole to look the spirit, because again, we are dividing the water, then the water will travel from top to down. So this is called the temperature here. So this is called the number of source 100 in this source. Sworn, I started just my one consideration. In the term of the numerical value, I have started with the 40 degrees. I can show you how to make the setting. I have started with the 40 degrees. So definitely will radiate the sum hit. Once they can travel here, then what happened if the traveling from here to here downside. And then we are going to see that like how much the temperature in the source, how more the temperature receiving in best plan. So this is our objective. So being a scientific student, being an engineering student, the engineer can decide that what is my optimum conditions to operate the device, what does me by the optimum conditions. Like what? Maximum pump utilization, I can use that. How much the maximum acceptable air, I can use that. So this kind of experiment, if you want, you can do that. And the live change of the temperature. You can see that how much here. Like I have to turn on the heater. Okay. Sorry. Or I just realized that like my temperature is not on. And because why not changing? So I am sorry. So I can go for the beginning, I can explain to this, okay, but if you want to run your lab, so the good thing is that like fashion can turn on this one and turn on the heater. At least recommended time is 1 hour before, because we have the water here so we can see the same difference here. But now I will just turn on the heater, accept the will, just ignore this point. I can explain to you, okay? So next about that, like what's parameter we have the speed of the how, the water traveling top to down here. We have adjustable option like how we can fit, and second that, like by the experiment, like way. Always trying to find out like what its optimum condition. So we can see that like water is coming here. We need to open, that was recommended, is like 50% of the strength of this one. And then here, this is called we can able to see that how fast and how slow, what is the cup according to the capacity of the pump. We are trying to feel the water from top to down. So sorry, we have the flow meter here and now. If you can come to here, the manual meter late also, like suppose you want to see that what is the speed of the air we are applying. So we have to use this one. I can explain to you how do you Amazon. The second thing is that suppose I want to see that the downside pressure and offset of the pressure. So you have to do this manometer. So you can see that like how much the air pressure was here and how much the air pressure was here, because objective is that to have to find out the energy loss schedule, what is happening is here, but our objective is that to loosen the temperature work coming from the processor. So now we have to move to the instrument side to understanding that like from the status, I want to start from here. The reason is that like in every device you must have the power supply. So we have the power supply here, this call, like we have